In this video we're going to continue with section 7.5. This is day 3. And the first thing we're going to look at are these power reducing formulas. The double angle formulas can be used to obtain the following power reduction formulas. Example 5 shows a typical power reduction that is used in calculus. And what we have here is a sine squared, and we can replace it with this quantity. And notice that we have our sine squared. None of these quantities are to the second power. So that's why we are power reducing. Here is cos squared, and we can replace that with this 1 plus the cos of 2u over 2. Whatever this angle is u, we double it to put it here. And we also have one for tan squared. Here's tan squared. That is 1 plus cos of 2u divided, or 1 minus cos of 2u over 1 plus cos of 2u. And here in example 5, we are going to rewrite sine to the 4th power of x as the sum of first powers of sines and cosines of multiple angles. So we want to get this. We don't want anything to be 4th power. We're going to get everything down to first power. And we're going to have to apply the power reduction formulas actually twice. First, we need to rewrite sine to the 4th. And our reduction formula has a sine squared in it. So we can rewrite sine to the 4th as the sine squared of x quantity squared. Sine squared squared is sine to the 4th. Now we can replace what I'll underline here in red, this sine squared of x, we can replace that with a power reducing formula. And that's going to be 1 minus the cos of 2x all over 2, and that is quantity squared. So to simplify this a little bit, I'm going to look at, we're going to sort of distribute this squared. I'm going to distribute it here outside of these parentheses, so that is a quantity squared. That 2 is also going to be distributed down here to the denominator. And when it's down here in the denominator, that 2 squared is a 4. And since it's in the denominator, it is under something else, we can drag that fraction sort of out front here, and it's going to come out as a 1/4. And then we have our 1 minus the cos of 2x quantity squared. So now the next step is to FOIL out this 1 minus cos of 2x quantity squared. So the 1/4 stays put. When we FOIL this out, we'll have our first term squared, 1, minus 2 times these two things multiplied together. Well, if we multiply them together, we get cos of 2x. So we're going to have 2 coses of 2x. And then our last term is negative, or minus cos of 2x times minus cos of 2x, which is plus cos squared of 2x. Okay, we applied a power reduction formula one time. We went from a sine to the 4th down. Now our highest powered term is a cos squared of 2x. So we're going to apply another power reduction formula to that term. And I'm just going to start rewriting this. We have our 1/4, 1 minus 2 cos of 2x plus. Now we're going to replace that cosine squared of 2x with the power reducing formula 1 plus the cos, and we double this angle. That goes from a 2x to a 4x. And that's all over 2. So let's see here, we did cos squared. Yeah, the cos squared we turned into this. And now, let's see, parenthesis on the end. Let's see, we'd like to get rid of this fraction here. This is a 1/2, 1 plus cos of 4x divided by 2. And what I'd like to do is sort of, to get rid of the fraction, I'm going to multiply everything within the parentheses times 2 to get rid of that fraction. And to keep it fair, I'm going to multiply on the outside by 1/2. So outside of the parentheses, we multiplied by 1/2. In the parentheses, we're going to distribute a 2. So we've basically done nothing to the equation. We've multiplied by 1/2 and by 2. 2 times 1/2 is 1. So we're just going to make this look a little different, but we won't be fundamentally changing the equation. So 1/2 times 1/4 is 1/8. And then we distribute the 2. 2 times 1 is 2, minus 2 times 2 is 4, coses of 2x, plus, and the reason we multiplied it by 2 was to wipe out this denominator, so we have our 1 plus cos of 4x. And then there's just one little final step. Inside those parentheses, we have a couple numbers that we can combine. We have our 2 plus 1. We're going to combine those into a 3. 1/8 times 3 minus the cosine, 4 times the cosine of 2x, plus the cos of 4x. And we rewrote from sine to the 4th power. We broke it down into as a sum of first powers of cosines and multiple angles. So here are our cosines. Our multiple angles are 4x and 2x. We've reduced power from 4th power down to 1st power. Next thing to look at are the half-angle formulas. You can derive some useful alternate forms of the power reduction formulas by replacing u with half u, or u divided by 2. The results are called the half-angle formulas. So the sine of some angle u divided by 2, or half u, is plus or minus this radical, 1 minus cos of u over 2. Cos of a half angle is plus or minus square root of 1 plus cos u over 2. And our tangent of a half angle, we can either use this 1 minus cos of u over sine, or we could use sine u over 1 plus cos of u. And notice the pluses and minuses here. The signs of these angles will depend on the quadrant. Remember, sine is a y value. That's positive in quadrants 1 and 2. Cosine is your x values. That would be positive in quadrants 1 and 4, negative in 2 and 3. So let's see here in example 6. It says find the exact value of the sine of 105. Well, we're learning about half-angle formulas. What is 105 half of? 210. 210 divided by 5 is 105. So we're looking at this as 210 over 2. And if we start to plug that into the sine formula, we're going to have the sine of 105 is equal to plus or minus, and then we have our radical. And under that radical is 1 minus the cos of this doubled, this 210 degrees, the cos of 210, all over 2. And this 105 is not on our unit circle. That's why we have to use this alternate method. If we go to the unit circle, we do have 210 on there, though. So we're going to have plus or minus 1 minus. The cos of 210 is negative root 3 over 2. That's a 2. And this is all over 2 here. And under the radical, we will add the opposite. So underneath that radical, it becomes 1 plus root 3 over 2 times 2. And underneath that radical, I don't like we have a fraction within a fraction. If I multiply this numerator times 2, I'm going to also multiply the denominator times 2 to be fair. Oh, and we are in sine of 105. Let's see here. 105 degrees would put us somewhere in quadrant 2. Sine values are y values, so we would be positive in this quadrant. So we can also throw out the negative sign. We know where we're located. So to multiply through by the 2, in the numerator, 2 times 1 is 2, plus, this 2 will take out the denominator 2, and that will just become a square root of 3. And then our denominator is 2 times 2 is 4. Now remember, one of the properties of radicals is, in a fraction, we could just do the radical of the numerator and the radical of the denominator. So we're going to have our numerator as 2 plus the root of 3 over square root of 4 is 2. Now look at that. We have a root within a root. We have 2 plus the square root of 3 all under the radical, all divided by 2. And now it's your turn. Pause the video, try these two huddle problems here. This is very much like the first example. This is cos to the 4th of x. You want to reduce it down to all first powers. So your first step, of course, just like we did with sine to the 4th, this is going to be cos squared of x, quantity squared. And then model it after the first example. Let's see here. In the next one, we have find sine, cos, and tangent of 75 degrees. Well, 75 is going to be 150 over 2. So you'll use those half angle formulas, and you'll look for the sine, the cos, and the tangent of this. So pause the video and try them. Okay, let's see this first one here. Oop, and I shouldn't have erased my clue I gave. So this is cos squared, quantity squared. And we replace inside the parentheses here, that cos squared becomes a 1 plus the cos of 2x all over 2. And this quantity is squared. And just like we did with sine, when we were doing this first example, we're going to make this quantity squared, distribute the squared to that, and also down here to the 2. And then we drag this out front as a fraction. In the denominator, that is a 4, so out front, we're going to have a 1/4. And then we're going to have 1 plus the cos of 2x, quantity squared. Next step is to FOIL out that binomial squared. And we're going to have 1 plus 2 times the cos of 2x plus cos squared of 2x. And then we have to deal with another cos squared. So we're also going to apply that formula again. So we're going to have our 1/4 stays put. The 1 plus 2 coses of 2x is there, plus, now we replace this with 1 plus the cos of double this angle, 4x, over 2. And just like the very first example, I'm going to sort of multiply inside the parentheses by 2. I'm going to distribute a 2. And to balance that out, I'm going to do a 1/2 out front. So just like the sine example, we're going to have an 1/8 out front. 2 times 1 is 2, plus 4 cosines of 2x, plus 1 plus the cos of 4x. And then you combine the 2 and the 1 and get a 3. 1/8. 3 plus 4 cosines of 2x plus cos of 4x. And in the last one here, use the half angle formulas on 75 degrees. So let's see, the sine of 75 degrees. We know that's quadrant 1. Sine values are going to be positive. And our half angle formula is 1 minus the cos of double this angle, 150, all over 2. 1, and then the cos of 150 is negative root 3 over 2, all over 2. And this will, minus a negative is adding. And then we'll multiply the top and the bottom, our numerator and denominator, under the radical, times a 2. So now we're going to have 2 plus the square root of 3 over 4. And break that into separate radicals. The radical of just the numerator, 2 plus the root of 3, all over the square root of 4 is 2. So there is our sine value. Sine of 75, root of 2 plus root 3, all over 2. The cos of 75. And let's see here, we're in the first quadrant. Everything's positive in the first quadrant, so cosine is also positive. So in front of our radical, we don't need the plus or minus, it's just positive. And this formula is 1 plus the cos of double this angle, 150, all divided by 2. The cos of 150 is minus the square root of 3 over 2. And that's all over 2. And you start to see a pattern emerge. We got to multiply the numerator and denominator by a 2. And we'll just have the radical of the numerator, 2 minus root 3. Denominator would be 2 times 2 is 4, and the square root of that is 2. So a lot like the other answer we got, but there's just a sign difference. So the cos of 75 is the square root of 2 minus the root of 3 all over 2. And we could do tangent is sine divided by cosine, but let's take the formula for a spin. The tangent of 75. That's a better 5. That's equal to, our numerator is the sine of double the angle, 150, over 1 plus cos of double the angle, 150. And let's see here, the sine of 150 is a half, and that is all over 1 plus the cos of 150 is negative square root of 3 over 2. So that's going to be a minus square root of 3 over 2. And this is going to be real convenient to get rid of these fractions within fractions and multiply by 2. So up top here we're going to have a 1 over 2 minus root 3. And for a little more practice here, use the power reducing formulas to rewrite the expression in terms of the first power of cosine. So now it's sine to the fourth of 2x. So this is a lot like the first example, but now there's a multiple angle in there. So it's going to change a few things by the end. In the next one, 63, use the half angle formulas to determine the exact values of sine, cosine, and tangent for, now it's in radians, pi over 8. So pause the video and try those problems, and then start her back up. Okay, if we model this first one right off the introductory example, this is going to be sine squared of 2x quantity squared. And we work with our first power reducing formula. This is going to be 1 minus the cos of double this angle, 4x, over 2 quantity squared. So we're going to sort of distribute that squared to the numerator and the denominator. And down in the denominator, that is a 2 squared or 4, and we can drag that out as a fraction 1/4, 1 minus the cos of 4x quantity squared. And we're going to FOIL out the binomial. 1/4, 1 minus 2 cosines of 4x plus cosine squared of 4x. And here we have another cos squared, so we're going to apply the power reducing formula again. So we'll copy the problem with most of it intact. And now this cos squared of 4x becomes 1 minus the cos of double this angle. Now it's up to an 8x all over 2. And to make this look a little prettier, we're going to multiply everything inside by a 2 and the outside by a half to balance it out. And I'll go back up above it here. So 2 times a fourth is an eighth. You know, that's a recurring theme on these problems. 2 times 1 is 2. 2 times 2 is 4 cosines of 4x plus 1 minus cos of 8x. And just like we did the other 2 times we've done problems like this, we have a 2 and a 1 to combine. Those just become a 3, and then minus our 4 coses of 4x minus the cos of now 8x. So the answer looks a lot like what we saw in the first example. It was just different because we were starting out with a multiple angle. In the original example, it was just the sine to the fourth of x. So let's use our half angle formulas here to find sine, cosine, and tangent of this angle pi over 8. And pi over 8 is equal to 1/2 of pi over 4. Or it might be easier to see how we're sticking it into that formula. This is going to be pi over 4 over 2. A half of pi over 4 is pi over 8. So when we're using these formulas, what we stick in is going to be this pi over 4. So let's start with sine. The sine of an eighth pi is equal to, we're going to have a big square root. And let's see, we're pi over 8, that's definitely first quadrant, so everything is going to be positive, sine, cosine, and tangent. And we start out with, underneath this radical, is 1 minus the cos of this angle, pi over 4, which is on our unit circle, and that's all over 2. So, the cos of pi over 4 is square root of 2 over 2, and this is all over 2. So, multiply the numerator and denominator by a 2 and break it into separate radicals. So our numerator is going to be 2 minus the root of 2 all over. That'd be 2 squared is 4, and the square root of that is 2. The square root of 2 minus root 2 all divided by 2. That is the sine of an eighth pi. Now on to cosine. The cos of pi over 8 is equal to, again we're first quadrant so everything is positive, under our radical goes 1 plus the cos of a quarter pi, all divided by 2. The cos of a quarter pi is root 2 over 2, so it's going to be 1 plus the square root of 2 over 2, all divided by 2. Multiply top and bottom by 2, separate the radicals. We're going to have 2 plus the root of 2 over 4, we're square rooted, which is 2. So look at that, the cos of pi over 8, very similar, just a sign difference. 2 plus the root of 2, all over 2. And finally, tangent. The tangent of an eighth pi is equal to, our numerator is sine of a quarter pi, and our denominator is 1 plus the cos of a quarter pi. And let's see, on the unit circle, if we go to pi over 4, our sine value is root 2 over 2. 1 plus, our cosine value there is also root 2 over 2. And this 1 here, we could think about that as a 2 over 2 to get a common denominator right off the bat. So here we have square root of 2 over 2. Our denominator is going to be 2 plus the root of 2 over 2. And here we would invert and multiply. Oops. So a fraction divided by a fraction. I'm going to bring this one up and flip it. Now the 2 is the numerator, 2 plus the root of 2. Oops. 2 plus root 2 is the denominator, and we're multiplying. So the 2's on the diagonal will cancel, and we're going to be left with up top a root of 2. Our denominator is 2 plus the root of 2. And let's just leave it like that. Assignment for this section, page 582 and 3, these 5 problems. Make sure when you read the directions, look, they might be asking you to find the sine, cosine, and tangent of the angle.